this week's practical, we are going to be looking at extreme sea levels at Portsmouth and calculating return periods. We're going to download data from the British Oceanographic Data Centre and also look at some UK sea level projections as well. So as always, you should have two folders in your folder, a code and data, everything really nicely organised. Now, I'm almost positive a lot of you will have very unorganised folders and have mixed up where all your code and data is. Please do try and tidy those up, because particularly when you do your assignment, being organised and having everything in neat folders really does help. Okay, so I've downloaded the template. I'm going to open that up. Okay, so as always, we start by clearing the variables from the workspace, clearing the screen. It's just always good practice to do that. And then we're going to set up a site ID. Now, in all of the previous practicals, these have been numbers, but now we're going to use data from the BODC, which rather than has numbers, it has 3-letter digit codes. So PTM stands for Portsmouth. Okay, now we're going to go to the British Oceanographic Data Centre website. Now you will need to register for an account here. I've already logged on, but up here there'll be a register. So once you've registered, it might take a little while. You need to go for search data, UK tide gauge network here. Okay, and what you're going to do is you're going to download processed annual and monthly files. There's lots of links and clicks here. I don't know why they have so many, but download quality control tide gauge data. And I tend to use this form-based selection tool. It's a little bit easier here. So what I want is the actual water level values plus the residuals, the storm surges. And here I'm just going to select Portsmouth. I'm going to have, it seems to be data available to 2022. I'm going to have the primary channel. The datum, I'm going to keep that the same. And what I want to do is add selections to my list so I can update the data request here. So there are the years for data that's available. I can request this data now. Okay, now what I need to do is, normally it asks you to put in a reason, what you're going to use the data for. I just say research, have you got any funding? None. And then I click this link here and download the data. And it normally takes a minute or two to download the data. Actually, this one's quite quick today. Okay, so again, let's try and be as organized as possible. So go to my data folder. You'll see there's this folder called processed, and here are all the files here. So in fact, what I can do is copy them all over. Let's go back to our folder, pop them into data. Okay, now there's lots of different files, but this HTML one is quite good, and it tells you about the site, what the latitude and longitude are, percentage of good data each year, where there's missing values, what the tide gauge is, where the data's come from. But again, these are just text files, so you can have a look at the format. Now this format is a bit more tricky, so it's harder to read, but there's some header lines, there's a cycle number, there's date and time, and then there is the water level itself here. This is missing data. There's obviously but what's interesting is there's a little letter here, and that letter tells you the format of the data. So M means the data's improbable. We want to get rid of that. N is there's a null value, so we want to set that to an NaN. Actually, interpolated values we're fine to use. Okay, so now we are ready to load in the data. Okay, now what we're going to do first of all is use this. The data is a bit of a horrible format, so it's not as easy to use as in previous years. So what I'm going to do is just set up this variable called ops, and I'm going to detect import data. Now, because the data is all the same format, I don't need to specify a file heading here. I'll do that later, you'll see. But let's just load in 1 year of data. So 1991 ptm.txt, and let's run that. And this just gives us some inputs. So it tells us how the data is organized and headed and various things here. Okay, now what I'm going to do is use the do it all in here. Now I'm going to use the preview function, and I'm going to preview that file name and this variable that I've loaded in, and it gives you a preview for what the data looks like. So actually it's done quite a good job without me telling of it anything, that it's kind of found a cycle, it's found a date and year. It's got the headers mixed up, it's not quite right, but the key thing I really wanted this years, hours, and then the water level data and the residual data. So what I'm going to do now is say ops.variable names, and I'm going to tell it the variable names that I want. I'm going to separate them there. Now the first variable I'm just going to call n, that's the number. Then I've got a variable of year, month, day. I'm just going to call that, keep that simple. Hour, minutes, seconds. Then I have the water level, and then I have the surge, the residual. So that's really it's just these first 5 columns that I want to load in. I don't need to preview that because I'm going to come on to that in a second. Okay, then I know this is a bit confusing, but actually once you've done this once, you can do this for any data, and it's quite an easy way. So then I'm going to specify the data types. So columns 2 to 5. So this one, this one, this one, this one. I'm actually going to make them a string. It's easier than loading it in numbers, particularly because there's codes on the end here, and also I want to convert this to a date time anyway. Okay, I'm getting mixed up with my headings here, so I'll just copy these into the right place. Okay. Now the last thing I am going to do is which ones do I actually want? So I'm going to do selected variable names. So I actually don't want the first number. We don't really need that. All I want is the year and the month, the hours and the minute, the water level, and the surge. Those are the only ones I really want. And then we can just preview this. In fact, I can copy this in previously. But now that I've set what I want in this ops variables, when I do a preview and this ops variable, it should only give me what I want. You can see it's only loaded in the data what I want, and it's loaded it all in as strings, which is much easier. Now you can see I've hard-coded the file name in here, but it doesn't matter because any BODC data has this format. And when I come in to actually load in the data, you'll see I'll do it a bit differently. Okay, so I know that's a bit confusing and a bit complicated, but what we're going to do now is actually load in the data. And what I'm going to do is, because unlike with previous files, now we have to load in multiple data sets. So I'm actually going to do this in a loop. But let's start simply by just loading in one to start with. So our file name that we're going to load in, let's just load in the first year to start with. But again, this time I'm going to be a bit different in that I'm going to take out the year, take out the name, because we can replace that, because we want to be able to load in any year and any name. Okay, so let's do that, and let's specify a year. So the year is 1991. So here we can add the num2 string year, and then we can add the file name, and this is just SID. We don't need to convert that to a numbered string because actually up the top here it's already a string, it's already a character array. Okay, so this should generate the file name, and we should be able to add any year there. 1991, if we added 1992, it should update it. You can see that it does. Okay, I'm going to switch that off for the time being. I'm going to switch this off. Okay, now I'm going to read in this file t. T is read table, file in, and now I can specify this ops thing that I read before, which will, do everything I want to do. It'll only read in the columns I want to do as strings. So there you can see it's read it incorrectly. If I do 1992, it should load in 1992. Okay, so what we want to do now is convert this to a loop. Again, if you don't know how to use a loop, type help for, and we use a for loop. Okay, so what I'm going to say is for year is 1991 to 2022, the data there. Okay, and then every loop needs an end. So we're going to go through, I'm going to switch it off there. And now I'm going to loop through each year. So essentially each year it's going to loop through and load in the data. But what I really want is I'm going to say the date time 1. What I'm going to do is each time this t is going to overwrite. So I'm going to have 3 variables that I set up. These are going to be strings to start with, and I'm just going to give them a value of 0. So this is going to be the date and time, this is going to be the hours, minutes and seconds, and then I'm going to have the water level, and then I'm going to have the surge. Okay, so now what I can do is I can, each time I load in this data, I'm going to add it to the end. So dt1 will be dt1. The first time that one is just going to be full of zeros, but in the end I'm going to plot d.ym. So it kind of like appends it to the end. It's a clever little trip. Each time it loops through, it will take the year before and plug it to the end. This is our minute. Again, see how I'm cutting and pasting. Then we have the water level. The water level, this is going to be t.waterlevel. So this is going to load in each year, but each time it's going to add the data to the end. And just to be sure it's not overwriting anything properly, I'm just going to, after each time, I'm just going to clear the t. Okay, so now we can run that. It might take a little while, but it will load in all of the datas. And now you can see we have this massive whopping long data set here. We should have the data all the way from 1991 to 2022. So it's loaded in over 1 million values of data, and you can see it's done it quite quickly. So I know this was a bit complicated, but you can see once you get it to work and once you specify your options, actually it loads in things really nice. Now what we want to do is create a time string. So I'm going to add dt1 plus I'm going to separate them by a space and add dt2. So I'm going to add those two together, and then I'm going to overwrite that. I'm going to convert it to a date time. And here we can specify the input format. So the input format is, and you do need to look this up in the help menu because it's case sensitive, months are capital, hours are capital, minutes are small. I don't quite know why they did it. So this is the format of the data. We have year, 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 month, month, day, day, hour, hour, minute, minute, second, second. Okay, and we can run that. And now we should have our date and time correctly in date time. So we can actually now, if we wanted to, get rid of that dt1 and dt2. Okay, now you can see that the water level is a string. We want to convert that to a number, and we want to get rid of these letters, and anything that is an N, we want to convert to an NaN. So what we're going to do is we're going to use the contains function. So I'm going to say F1. F is important because it stands for, in my mind, for flags. Try and have variables. Well, one is try and keep the variables simple. So what I'm going to do is with ff1, I'm going to look for everything in water level that contains an M or contains an N. So again, this will be like a logical array. It'll be a kind of row number, but it will tell me which, sorry, it's taking a while because when I run this section, it has to load in the data again. So here's a logical array. So it will have a 1 or 0. So a 1 if it does contain an M and an N. So you can see, you can check it here. The first one does. Eventually we'll get down to one that doesn't. And then what I'm also going to do is F2 is the SU. Okay. And then what we're going to do is the erase. So water level is erase water level, and we're going to get rid of all of those things because we want it to be a number. So we're going to get rid of any M's, any N's, and any T's. So it's improbable, null, or interpolated. So we're going to get rid of those, and we're going to do the same with SU. And then what we're going to do is, now that we've got rid of those, we can convert it to a numeric, which is a double. Double just means double precision. In the older days, double precision meant it was stored to 18 versus 16. 16 rather than 8 decimal places, but double basically means it's a number, not a string in MATLAB. Okay, so now we should have the water level as a number, and it is, so we can start to plot this. But what we want to do is we just want to get rid of the flags. So water level, anything earlier that we flagged as 1 can become an NaN. So here you can see that 999 will be flagged. So and yeah, now we can convert it into a flag. And while that's loading, now that we've got the water level, we can calculate the tide. The tide is simply the water level by the surge. I don't know why the BODC don't give us the surge. It seems a bit strange to me, but I think for data space, they've left it out. Okay, now before we come on to plot the data, what I'm going to do is detrend the data, because the data will have a trend in there. In fact, we can go back to the command and just plot TS against water level just to have a quick look at the data. Here it is. You can see, it's quite hard to see, but the water level is rising over time because of mean sea level rise. Now when we do, you should have seen this in the lecture, but when we do an extreme value analysis, we need to get rid of the trends so that we can compare, because if you don't, you can't compare a date 100 years ago with a date now. But what I'm going to do is just use the detrend function. So I'm going to say water level D is detrend of water level. Now that will set everything back to 0. So what I'm going to say is J is year TS equal to 2019. Now I know 2019 has quite a bit of good data, so I'm going to use 2019 as my base year, and then I'm going to say water level D is water level D. I'm going to overwrite it, but I'm going to take the mean of the water level of just the J rows. So J tells me the rows that correspond to 2019, and then I'm going to add on the mean to 2019. So if we plot the D now, it will have been, oh sorry, I just need to run that, but if we plot that now, it will be the data but without a trend, but everything relative to so it'll be the same as 2019. So we can plot the water level, say as red, the original one. Sorry, for some reason it's bringing it to my other monitor. We can hold that on, and now we can plot the detrended water level as blue. And you can see that basically everything in 2009, but it's got rid of the trend. It's moved everything before 2009 up. Everything from 2019 is the same. So we've got rid of the trend there. Okay, and then our final step is just to create a times table, because there's lots of variable going on here. So a timetable is a really nice way of storing information. So you can load in the times and then load in our variables. I'm going to have water level D. I don't think we've done times tables yet, but timetables are a really nice way of storing data. And you can do some very clever functions on timetabling really easily, which I'll show you in a minute, using the retime. And also it makes plotting a lot easier. Okay, so now I'm going to put in the variable names, and I'm going to cut and paste these from here. But there's going to be 4 columns. So we're going to have the water level, the detrended water level, the tide, and the surge. It'll take a minute to run that. Okay, now you can see the first stuff is all flagged, so it's NaN, but later on we should see values that are not flagged. So we have a water level, detrended, and then we have the tide and the surge, those together should combine. Okay, so you've done your first 3 steps here. I know it was a bit tricky doing this, but once you've done it once, actually it gets quite easy, and now you can load in data of any single format and get it into exactly which format you like. And next we can plot the data and then do the fun bit of calculating extreme value theory.